Chances are that you are in a situation in which your development team has spent months building that AI application that was working perfectly well at demo stage. But despite having passed all the usual quality assurance tests, when the application hit production and users at a scale start using it, then hallucinations and inaccuracies surface. The reason behind the inaccuracies of your AI application in production is the stochastic nature of the LLM. Remember that the LLM, the large language models, or the LLMs that are used by your AI app are the actual components that fuels the generative AI features of your AI app. Okay, so being stochastic means that an LLM can come out potentially with different outputs given exactly the same input. Okay, so in every single AI application, there are three pillars that you need to measure in order to be able to know where are the root causes of the inaccuracies. And those three pillars are, first of all, the prompting, okay, or the how well you are specifying the LLM or the LLMs that your AI uses, how well you are specifying what needs to be done, okay? So you need a structured way to measure the quality of your prompt, not vibing, not as we did in demo stage, which are, okay, I'm gonna make Cloud Code to create a prompt, and I can just test with my criteria or with my colleague criteria how well are the results of those prompts, okay? But in a structured way, how good are the prompts? How good is the specification that you are giving to the LLM? The second pillar is the comprehension. The comprehension is actually how well the LLM pipeline of your AI application is understanding the external information provided. Okay, that is user questions. Okay, in demo stage, maybe you have a specific set of user questions, maybe 100 of them, 200 at most. In my experience, no more than 50 or at most 100 user questions, made out user questions that I've been able to test and measure the quality of those user questions. But when it comes to production, you need to measure a lot more, a myriad of user questions that probably you were not able to test in demo stage. Okay, so you cannot measure how well the LLM is performing about the comprehension, about integrating the external data on the LLM pipeline. Okay, external data, I mean, not only user questions, but also in a RAG application, for example, these are the documents that you are retrieving from a search engine or a database or an API request to an external service, okay? And the third pillar is the generalization. That means how capable the LLM or the LLMs your AI app is using to perform a specific task, how well is that generalization, how capable those LLMs are, okay? So you need to, if you are able to measure systematically with specific metric, those three pillars, specification, which are the prompts, comprehension, which are the how well your system incorporates the external information, and how well does your system generalizes, so you are going to be able to measure what is quality. If you have metrics for all of these, you have specific quality measures, okay, which is the final goals of AI evals, okay. One super important thing at this point is not, I mean, forget about one size fits for all. Every single AI applications has its own set of metrics on those specific three pillars, okay? There are no metrics there are no generic metrics for those three pillars that you need to measure. Instead of wasting tons of money and months of rework without significant results, what you need is a reliable AI eval system that actually pinpoints your development teams on what needs to be touched in order to improve AI accuracy, and also measure the specific metrics to your AI application related to its stochastic nature. There are a few approaches out there on AI evil systems. To pick an approach with reliable outcomes, just make sure that it's not tool centered. I mean, this is not a tool that you install and that's it. Then that has human in the loop in order to be able to humanly analyze data. Then has not generic metrics, and this is the most important one, is based on statistical error analysis. See you in the next video.